The Ho Chi Minh Trail, the enemy's lifeline to the war in South Vietnam and Cambodia, is an intricate and complex road system. Thousands of trucks racing and plunging along this maze of trails carry the materials of war. Materials of war that enabled the Viet Cong and North Vietnamese to terrorize and attack our allies and our own ground forces. Believe it, the trucks are there, but they're not easy to find. An enemy truck convoy can always divert from one road system to another, hide under the tiered canopies of tropical forests, park and refuel under camouflage, and because of our daytime tactical airstrikes, they always run under the cover of night. The only way to stop this flow of war supplies is to search out the trucks in the night, acquire them as targets, and destroy them with powerful and accurate gunfire. For this mission, the Aeronautical Systems Division has developed for tactical employment a remarkably successful weapon system for the Air Force, the AC-130 side-firing aircraft. Flying a small percentage of the interdiction sorties over the trails, the aircraft in this program have accounted for an impressive number of all enemy trucks destroyed or damaged. Night armed reconnaissance is the primary mission of these aircraft, but they're highly versatile. They're also effective in other night combat operations, such as interdiction strikes deep in enemy territory, close air support of troops, escort of ground convoys of friendly trains, trucks, and river ships. And because of their ability to locate and orbit a target and to see in the dark, they're frequently used as forward air controllers for fighter strikes. However sophisticated the weapon system is, it is only as effective as the combat crew who flies it. 14 of you acting as one. The great majority of your missions will be flown in darkness, and every one of you in the crew contributes to the accuracy of every shot as well as to the safety of every mission. Now, the whole trick in being a successful AC-130 combat team is to understand the basic geometry of the firing orbit, develop your skills in operating the sophisticated sensors, fire control system, and weapons, and to coordinate with one another in split-second timing. For all side-firing aircraft, AC-47s, the AC-119s, or the AC-130s, the basic firing geometry is the same. The aircraft flies a left-turn orbit in a 30-degree bank at a constant altitude with a specified true airspeed around an aim point. Now, this geometry establishes a definite slant range to the aim point that's superimposed over the target. For each different attack altitude, your guns are readjusted and fixed so that your fire will hit the aim point. For each attack altitude, a different sight line. Therefore, a different gun depression angle. Now, a sight line is a straight line, but of course, the ballistic path is not. There's a ballistic drop here that must be compensated for in the gun settings. Now, these settings are obtained by bore sighting on the ground. But when you're airborne, each gun must be fired to check the accuracy of these settings. It is this sight and gun angle adjustment that enables the aircraft to fly its 30-degree angle of bank for all attack altitudes. Now, notice that regardless of the attack altitude, the radius of the pylon turn will be nearly constant. The attack altitude and the true airspeed must be selected before entering the firing orbit. To compensate for the forward velocity of the aircraft, the guns are adjusted to fire slightly aft of the sight line. Now, this angle is called the gun lag angle. Obviously, as airspeed increases, the gun lag angle must be increased. Now, with your sight line directly on the target, your guns are aimed at a point might be about here. This compensates for the forward carry of the aircraft and for the ballistic drop. This simple firing geometry enables the pilot to zero in on his target throughout a prolonged attack, keeping the target under constant surveillance from 360 degrees. Of course, there's always something to complicate a basic theory: wind. Wind not only affects aircraft position and travel, it also displaces the impact point of the ordnance. The pilot will maneuver the aircraft to compensate for wind drift. He will increase his angle of bank on the downwind arc of the firing orbit. He will decrease it on the upwind arc. Now, as you can see, a 30-degree angle of bank can be maintained in these areas of the firing orbit. And it's from these arcs that he will usually fire. The aim point for firing will be offset into the wind, just as you offset for wind on the rifle range. Now, if your shots consistently group off target, that indicates an error caused by wind. Of course, on board a weapon system as sophisticated as the AC-130 side-firing aircraft, you have a computer that's quite capable of compensating for wind drift. Now, how do you crew members and your weapon system fit into this geometry? Let's start with the gunners. But first, I better explain that the pictures we're going to show you are not of the photographic quality of the film you're looking at right now, but the training and combat photography and the battle damage assessment footage will give you an idea of what you will actually see, how the fight really goes. So now let's get with those gunners. On the other side of the bulkhead, behind and below the pilot, is the forward gun station. These first two guns are 20-millimeter Vulcan cannon with a rate of fire of 2,500 rounds per minute. They're manned by two forward gunners, and when these cannon are fired, you two men will be busy loading and manning. The third and fourth guns are the miniguns, 7.62 millimeters. They have a rate of fire of 3,000 or 6,000 rounds a minute. They're used for strafing in special situations, such as support of friendly troops in contact with the enemy. They're manned as needed by one gunner from the forward or aft gun crews. In addition, one of the gunners must man the right forward scanner position. The fifth and sixth guns, the 40 millimeters, are the truck killers. And they're as accurate as sporting rifles. The long reach of these guns gives you a greater slant range. That means greater standoff distance, which greatly reduces your vulnerability to the enemy's anti-aircraft artillery, AAA. The gunners who man the 40s will be spelled and helped by the two forward gunners. In hostile areas, that AAA has a bad habit of coming up at you. Every man in the crew who can see it watches for it. But one crew member is a specialist. He's the illuminator operator, and his position in the aircraft is unusual, to say the least. He lies prone on the open ramp in the rear and watches below for AAA. If it's coming directly at you, he calls it accurate, and the pilot takes evasive action. If the AAA angles away from you, he calls it inaccurate, and the pilot continues in the firing orbit. While he plays this tricky game, he drops ground markers. When they light up on the ground, a fighter strike can be called in against the AAA gun bunkers. If you have what it takes to be in this crew position, you'll also operate the 40 kW illuminator and the flare launcher when they're installed. The sensor operator's booth, located on the right in the center area of the cargo compartment, is acoustically treated to keep out the bang and roar of the guns. It's air-conditioned, protected by steel armor, and covered with ballistic repellent material. There are 3 officers who operate the sophisticated sensors and a fire control officer who coordinates sensor operations. The electronic warfare officer operates several sensors. For example, Black Crow, a specialized electronic sensor, and the beacon tracking radar. Using the Black Crow sensor, he will usually be the first one to detect a truck moving along a trail. That radar is used principally to locate a friendly troop position where a transponder beacon is located on the ground. In bad weather, which is when the enemy is likely to attack, this can be of the greatest importance to ground forces. In such a situation, fire support is directed against the enemy an offset distance away from the friendlies. This officer also operates the Trim 7 and other advanced electronic countermeasure systems, the infrared reconnaissance system, the low light level television, and the 2 officers who operate them are the real night eyes of the AC-130 weapon system. The infrared sensor, the IR, is an extremely precise heat sensor. So sensitive, it can detect minute temperature differences and show it in real-time imagery, much like black and white television. Target images are magnified by a factor of 4, and the aiming reticles are etched into the display. If you're the IR operator, you will learn there are many tricks in operating this sensor, and it's your job to know them all. You can see through haze when the TV cannot. You can search the roads beneath with a wide-range picture. You can change scale for a close-up look. You can select white-hot or cold-hot polarity, depending on which mode shows the target best. Jungles are cool, roads are warm, and running truck engines are hot. There are lots of questions, but you don't have to answer all of them by yourself. You're part of a team, and you can always cross-check with the TV operator. Either one of you can slave his picture to the other fellows. Television needs only moonlight or starlight to present you with a picture of the Earth below. The 2 kW illuminator is slaved to the TV to brighten the image on a dark night. That illuminator, a xenon arc lamp of extreme intensity, can be operated in either a visible white light mode or in an invisible IR spectrum. It is always operated in the IR mode while in combat, so that it is not visible to the enemy below. A distinct advantage to the operator of the TV is its narrow field of view that enlarges the target by a factor of 6. Every man in the crew who is acquiring or tracking a target is measuring the aim point in terms of mils. Everybody's talking the same language, but that's still a fine sighting to make from a moving aircraft. If you're sighting and firing along a 12,000-foot slant range, 1 mil of tracking error, and you miss the target by 12 feet. For the IR and TV operators, that means stay steady. Track your target slowly and evenly, and lead a moving target by about 2 lengths for every estimated 10 miles per hour of the truck's travel. If it's a truck convoy, destroy the lead truck first. That jams up the convoy.
You guys see in the open or something like that?
In the open, roger.
You're cleared. Yeah, we got Bo with us.
Up by
Yes, sir.
TV.
Okay, just sped up considerably.
He is a mover, and he has got his lights on.
We're gonna meet him.
He's slowed down considerably, but he's still moving. There's another one up the road. TVS up.
Okay.
Okay, down 300 feet. That's all right, not right.
Let's take the lead one, Charlie.
Roger that.
Okay.
Oh.
Look at that. Sorry.
We got dozens. I don't have a gun.
You need to go down 300 feet.
I want a gun.
You got one?
I want to stop him.
1,
45.
4.
They're stopped.
6 trucks.
Okay, pilot, we're all right. Stop. Let's get it on.
Okay.
Hit on.
Go.
Hit on number 2. Hit on number 2.
I can't say it, we're breaking out.
And what kind of airspeed you want to have?
28 max.
Roger, give it back, gunners.
There, one just blew up.
Roger.
Yep, the truck that was on fire blew up.
You come up at 106.05.
And pilot, we're going to move down the road as far as blocking this out. We're moving down to truck number 5.
What are we doing that for?
We cannot see the other trucks that go
okay. Sorry, he just blew up again.
And that fire is big enough to blow all the trucks on the curve. In fact, it's blocking my truck out now.
Roger, we just got some more trucks.
Oh, beautiful.
Yeah, I think we got them all.
Oh, rip.
Uh-oh.
Get out of here. Let's break right. Keep your head in. Keep your head in. Keep your head in. Don't.
Underneath.
Don't let me go in first.
Turn around.
Keep on this.
6 o'clock, 10 more rounds. 3 o'clock.
Keep on the stick.
Going at us.
Keep on the stick. Brother.
There's one other sensor switch that's particularly important. The consent switch on the operator control panel. When you depress the consent switch, you give the pilot a light signal that tells him you're on the target. The firing circuit is interrupted when the switch is redepressed and the pilot cannot fire in the automatic mode. What happens to all this target information you fellows are picking up with your sensors? It goes into the very heart of the weapon system, the fire control computer. The fire control officer determines which sensor has the best picture of the target. He computes and gives data corrections to the navigator when shots miss the target. In the AC-130A models, the analog fire control system on the flight deck displays the target information for the navigator. The navigator keeps the computer continuously updated with modifying information such as wind direction and velocity, corrections in azimuth and elevation, heading and slant range, true airspeed, coincidence, and target offset. This is the information that is passed to the pilot. It is registered continuously on his steering indicator and in his optical gun sight. Guided by this computerized information, he flies the aircraft into the attack orbit. That's when he turns into his side-mounted optical gun sight, and as he does so, he calls for armed guns. The flight engineer arms the gun that has been selected and that is on the line. In the gun sight, the pilot refines his aim by maneuvering the aircraft so that the fixed and movable reticles are superimposed. The navigator confirms that the target is clear of friendlies, and he coordinates the clearance to fire. The sensor operator is tracking the target. The consent light is on, and the pilot triggers off the shot.
Direct hit on one of the trucks.
Just roll 10 o'clock, no sweat.
No sweat.
Turn around.
Okay, we're, direct hit on the same truck. Some barge look like it's drifting away from the water or from the shore.
No, not.
It's got right in them.
Not if it has. It has drifted very
Direct
far.
hit. Direct hit. Here we have a fire on the barge.
Oh, up to the middle, huh?
Roger that.
Okay, that's target 4. Boat number 1. You got balls. I can see that, Willis.
Ship.
Destroyed, it's burning.
It's a ship. Ship of the line. 16-inch guns.
Go pilot now. We're on the 307 for 78 off of 94. He's got us. Oh, there.
No.
5 aft, 6 high. Group was good, started out 2 aft.
Okay, hold it down. That's going to knock out the rest of the truck. Let's get to him.
They got on IR. Holy mackerel.
They've really proven themselves far beyond expectations. Now, in the follow-up AC-130E program, one that we call PAVE Spectre, the weapon system is even more advanced. A new additional hydraulic system, very extensive armor plating have been installed to protect you and your equipment. An advanced digital computer provides increased flexibility to the fire control system. This enables the pilot to fire accurately even though he's not on nominal bank, altitude, or true airspeed for the selected attack orbit. If your shots miss the target, the fire control officer simply clicks in the miss distance and direction. Whatever's caused the error, wind, gun setting, sensor alignment, or aircraft skid, the computer computes the proper azimuth and elevation corrections, and that next shot should be on target. Besides the digital computer, the aircraft in the PAVE Spectre program are equipped with a heads-up display that gives the fire control officer and the pilot additional information and greater accuracy for every shot. This is a sophisticated weapon system operated by a skilled crew. The co-pilot monitors airspeed and altitude, and he makes what flight adjustments are required of him. He's also the man who's coordinating with the gunship's fighter escort. Besides his job of precision navigation, the navigator is in contact with the airborne command post, and he coordinates the clearance to fire. He plots friendly positions and keeps the battle log. Along with coordinating and selecting the tracking sensor, the fire control officer is responsible for pinpoint corrections in the fire control system, and he advises the pilot. He operates the battle damage assessment recorder and calls the results of all firing to the crew. He also records additional information for subsequent attacks and for post-mission analysis. Beyond his usual engineering chores, the flight engineer coordinates with the gunners on a private intercom, and he arms the guns selected to fire. The gunners must keep ahead of the guns, keep them constantly loaded, ready, and on the line. One gun jams, and instantly they have another on the line. Their guns are always ready for the next shot at the next target. A target the sensor operators are constantly searching for, acquiring, and tracking. And let's not forget that scanner, that illuminator operator, lying out there on the open ramp, calling and marking enemy anti-aircraft artillery. All this is going on at the same time. 14 men linked together by 3 separate intercom systems, acting together as one team. The AC-130 side-firing aircraft, developed for the Tactical Air Command, are becoming constantly more sophisticated.
105 howitzer, on the line.
But the greatest thing about the AC-130 side-firing aircraft will always be the combat crews who fly them. There's no substitute for skill and guts.
Big one.
TV's track.
That's a big gas truck.
TV's and fighter stuff.
Yeah.
Flash the Dundee. Okay, you gotta climb now.
Okay, we're going up.
And I still don't have secure on 2. Pilot, 2 drivers got out and are running to the rear. 3 drivers.
Affirmative, TV, Adam also. They're calling you.
There goes the truck again.
It's moving.
He's moving again.
Fire.
Slow it down. Oh, he's moving into the woods.
Oh,
Well, they're way behind me now. Level off.
No, wait a minute. They jumped it off the road. It's
yeah,
falling
they
down.
jumped it. Yeah, they jumped it.
The thing rolled off the cliff.
Here it goes.
There it goes, TV's.
All right, we don't have to shoot it then. We'll just nail it in a minute.
Just exploded. Negative.
No.
Shitty, you want to go up?
Yeah, just keep her coming up. Okay, are we in good shape now?